In this demo, we will implement the use case we covered when describing the command pattern. The first thing we'll need for that is a bit of plumbing code. We need classes for our employee, for our manager, and we also need a repository. Let's start with the employee. This is a pretty straightforward class. It mimics an employee. Every employee has an ID and a name, and we use a constructor to convey meaning that we want this employee to be initialized with an ID and a name. And then we have a manager. A manager is also an employee, so we let it derive from the employee class. But next to being an employee, a manager also manages a bunch of employees. We mimic that by adding an employee list. So with these two classes will work. Then we need something to manage these classes. Or rather, for our example, we need a way to add employees to a manager's list, remove employees from it, and check whether or not an employee is already in the manager's list. We can do that via a repository. First, we add an interface that defines the contract of our repository. This acts as the interface for the receiver, which is one of the components from the structure of the pattern. As you can see, it has the three methods we already talked about and one additional method, write_data_store. That's simply a helper method we're going to use to write out some info to the console output window. Like that, we can see what's going on. Now we need to implement this repository. I'm going to paste that in so we can run through it. So, as far as the data store is concerned, we're going to use an in-memory list. In a real-life scenario, you would probably want to persist this to a database somewhere. But for the pattern implementation, that is not important. This is not where the focus lies. But we do need something to mimic this, which is why we hold a list of managers as data store. And then we have methods to add employees to these managers from the data store. So we have one method that accepts a manager ID and the employee to add it, another one to remove it, and then one more to check whether a manager already is managing an employee. We can use this to check whether or not adding the employee can go through. Lastly, as mentioned, the write_data_store method is just a helper method which will write out the data store to the console output window. So with that, we've got our plumbing code, and we also already have the receiver. This receiver is the action that will eventually get executed when the command gets executed. The first thing we need for that is an iCommand interface. That is the command from the pattern structure. In the pattern structure, it contained just one method, execute. But as you know by now, these patterns should be seen as templates. In real-life implementations, additional methods or variations often exist. And this is such a case. We will immediately extend the pattern with an additional action, can execute. You can use this to check business rules that might block the command from executing. Like that, executing the command and knowing whether it can be executed are both contained within the command itself. The next class is the concrete implementation of a command. We name that add employee to manager list. We want it to implement the iCommand interface. So if we do that, we see that we have to implement can execute and execute. Our command needs a few things to be able to correctly function. It needs access to our repository, but it also needs to know the manager ID and the employee. That's the state of the command. Seeing we need all of these for the command to correctly function, we can convey that by adding a constructor that accepts these. Like this, we state that the command shouldn't be constructed without them. And we store these in private read-only fields. With that, our command now has access to everything it needs to correctly function. Let's implement the can execute method first. As an example, we will ensure that a command can only be executed if the employee isn't already an employee on the manager's employee list. We also add a null check to ensure that the employee we want to add isn't null. Additional rules can exist as well, like ensuring that an employee can only be managed by one manager at a time. But for demo purposes, this is sufficient. On to the actual execution of the command. That's the execute method. In this method, we add the employee to the manager's employee list. But if we try to do that, we see that we get a warning. This warning states that employee may be null. And that is true. We do add a null check in the canExecute method, but that doesn't mean that the execute method can't be called without first calling the canExecute method. So it does make sense to add an additional null check here. And there we go. With that, we've got our command. Then we need something to invoke this request. That's the invoker. In our example, the command is invoked by a user clicking a button in a user interface. So the invoker could be that button, either via a binding or by setting the command in some other way. And that works, but we haven't got a user interface. We're building a console app. And that's okay, because what I prefer to do is add a small manager class in between, a command manager, which is responsible for effectively invoking commands. Not just one command, but multiple commands throughout your application. In our demo, we can use that command manager as an invoker class, which makes our life a little bit easier. At this moment, the command manager class is pretty straightforward. In real life, the user interface would now call into the command manager to execute the commands. You'll notice that working like this makes it easy to add in additional functionality, like undoing commands. More on that in an upcoming demo. In this iteration, the command manager simply acts as a pass-through class that doesn't really do anything, but we will build upon this. For now, this is sufficient. Then on to the last part, the client. That's our program class. Let's new up our command manager and our repository. For that, we need to import the command namespace, so let's do that. And then let's create a command and invoke it. For that, we use the command manager. We call invoke on it, and we pass through a new command. To new up the new command, we need to pass through the repository, an ID for the manager, and an employee. Once the command has been invoked, we write out the data store so we can see what just happened. And let's try the same thing 2 more times. Let's give this a try. And let's put the output next to our code. So we have 2 managers, Katie and Jeff. At the beginning, they don't have any employees. We add a new employee, Kevin, and we write out the data store. That results in Katie having Kevin as an employee. Once we invoke the second command, Clara is added as an employee for Katie. And as we see, this works as expected. Lastly, we add Tom as an employee for manager Geoff, and that works out as expected as well. So far, so good. Now, what would happen if we try adding the same employee again? Employees are identified by their ID, so newing up another command and invoking it is what we're going to try. In principle, seeing in the invoke command, we check whether the command can be executed, and in the canExecute method, we check whether an employee is already on the employees list for a manager. This should result in the employee not being added. The command, in other words, will not be executed. And let's see if that checks out. And that is indeed the case. This is our data store right after we add Tom for the first time. And this is our data store right after we tried to add Tom for the second time, which obviously resulted in the command not being executed. And with that, we've got our pattern implementation. This is already quite useful, but we can extend this example so it becomes more useful. We're going to do that by adding undo functionality in the next demo. Time to extend our example with undo functionality. And this is where our command manager will shine. To enable undo functionality, we need to add two things. Let's scroll up a bit. Here's our command. And let's think about what undoing a command would mean. Seeing executing a command, in our case, means that we add an employee for a manager. Undoing this command will mean that we want to remove the employee from the manager. So our undo action is quite straightforward. We call into remove employee on the repository after a null check. On the command manager, we can then keep a list of commands. Seeing undoing means executing the undo actions on each command in reverse order, a stack is a good structure to store these commands in, due to the fact that it's a first in last out structure. So, when a command has been executed, we push the command onto the stack. And then we can add one or more undo actions on our command manager. Say that we have an undo action that will reverse the last command. The first thing we do is check whether there's still something on the stack. And if there is, we call pop. That results in the last item on the stack being returned. If it's not null, we call undo on it. And I see that undo doesn't resolve. That's because we're working on I command, so the interface. And I think I just added the undo action on command, but not on the I command interface. So obviously, I need to add it here as well. There we go. That should fix it. And indeed, now it resolves. What I also like to do is add an undo all action. The idea is that this one will reverse all commands. It's a bit easier for the client to interact with the command manager like that. And that's already it. Let's adjust our client a little bit so we can test this. So let's say that after we add Kevin as an employee, we undo that and we write out the data store again. And in the end, we undo all the actions we previously executed. So we should end up with a data store with two managers without employees. Let's have a look. So, the first time our list is written out, Kevin has been added. Right after that, we undo the last command, which means that Kevin is removed again. After that, our commands all get executed, as we know from the previous demo, and the last statement we do is an undo all statement. This means that all commands have been reversed, and that results in the same situation we started from. All managers have 0 employees. In a likewise manner, you could now implement redo functionality. Let's have a look at this and additional pattern use cases.